Hey guys, Alk here. Today we're discussing VRC parameter drivers. Parameter drivers can be used to set the value of parameters throughout your animator stack. This can be incredibly powerful for creating robust, clean, and scalable systems, and is almost essential when creating complex systems. I've set up a case which will help demonstrate how parameter drivers work. First, we'll look at one solution that's not using parameter drivers, and then find out what's wrong with that solution. After that, we'll come up with a better solution using parameter drivers. Now this is the case. Create a system where the visibility of the objects is controlled by what color they are. If the cylinder is red, disable the cube and enable the sphere. If the cylinder is blue, disable the sphere and enable the cube. If the cylinder is white, enable both of the objects. You may either take the time to attempt your own solution, so pause the video right now and come back in a couple seconds and we'll discuss a solution, or just wait a couple seconds. Welcome back. So let's take some time to discuss a solution that you might have come up with as well, and that's using AnyState to create color profiles. So let's take some time to dig into the state machine here. So what I've got is an entry that leads into a default state, which is the white cylinder that has a white cylinder motion. I've got a transition from any state to white cylinder that has the color parameter equals 0. And then I've got another one that leads into red cylinder for when it turns 1. And then I've got another one for when it turns 2 for a blue cylinder. So let's actually run this and see what's going on. See if we meet our requirements. So I'm testing this with AV3 emulator. I'll put a link in the description of this video for where you can download this. It's free. Once you've got it installed, all you need to do is go to Tools and hit this, and then you can do the same thing that I'm doing. So by default, it's white. That's correct. So if I click color red, it turns red and the cube disappears. If I hit blue, the sphere disappears and I'm back to white and everything is visible again. Okay, it works, great. But what's wrong with this? Now, let's open up one of the animations. Let's open up white cylinder. The problem lies in the fact that the visibility of the object is directly linked to the color of the cylinder. In other words, we are forced to create animation files that try to do too many things at the same time, which would result in tightly coupled, unscalable, and inefficient systems. What if there is a way to separate each requirement that we had into its own animation file and separate this layer by requirements? Because if you can remember, everything that we have, all of our requirements are all stacked into one single layer. Now, this is possible with parameter drivers. So let's take some time to walk through a solution that works with parameter drivers. Before we can actually start working with parameter drivers, the first thing we need to do is we need to start splitting the animations that we had by requirements. So this means that if we open up the animation tab right here, we can see that there are actually 3 things going on here. We are turning this cube on, we are turning the cylinder blue, and we are disabling the sphere. And that's 3 different things that are going on in one animation file. So the first thing that we do is we start separating that logic into different animation files. So I've got one for turning the cylinder blue. I've got one for hiding the cube, hiding the sphere, making it red, showing both, showing the cube, showing the sphere, and turning the cylinder white. All right. All right. Now that we've separated our animation that we had by requirements, we also need to split our big layer that we had by requirements. So this means that I now have a new layer for each single different requirement, meaning that I've got one for turning the sphere on and off, I've got one for turning the cube on and off, and I've got one for turning the cylinder white, red, and blue. Now I do like to mention that I am working without write defaults here, so if you are not sure what write defaults is or why you should not be using it, then I'll make sure to put a video in the description by Cam on this topic. He explains it fairly well, so do make sure to give that a watch. So moving on. All right, let's take a look at our parameter drivers layer. So you might be able to see that this is exactly the same layer setup as we had it before with our color profiles, except that if I go in my white cylinder state, you can see that I now have an empty animation in here. Why is that an empty? That's simply because we've moved the logic of turning the cylinder white over to our white cylinder layer. And we also have a new component here. This is probably the most important thing of this whole system. This is pretty much the core of this whole solution. What is this doing? This driver is capable of manipulating and changing the value of parameters throughout my animator stack, meaning that I can change the value of whatever Boolean I have, make it true in a certain state. So if I'm in the white cylinder state, I am changing the value of my cube Boolean and I'm making it false. Same thing can be said for my sphere. So this is really cool because it means that I can change the value of my parameters in my states, in addition to manually changing it in the VRC menu, of course. So the same can be said for all of these different states over here. So in this one, I've got, according to my requirements, I have the cube being true, and then I have the sphere being false. And same thing can be said over here. I do want to mention that the way that I've got this set up is that if it's false, that means it's active, and if it's true, it means it's deactivated. All right, so let's take a minute to look at our menu that I've got set up for the system. So I've got three different options here, one being white, one being red, and one being blue. For white, I got 0, for red, I got 1, and then for blue, I got 2. So this is all linked up to a integer parameter called color here. And I do want to mention, for what I'm doing, you can actually use Booleans. I'll make sure to put a video in the description that explains how you could. Like the only gain that you get from doing it with Booleans is memory optimization. But just for the sake of this tutorial, I'm doing it with integers. But just so you know, you can do this with Booleans too, what I'm about to do. All right, and then I've got a cube bool and I've got a sphere Boolean, which I'll go over in a second, what these do, why they're here. So if I look at these transition arrows over here, our color parameter is linked up here. So I've got color equals 0 for white, color equals 1 for red, and then color equals 2 for blue. All right, the only two things that I haven't covered just yet are the cylinder layers over here. And I feel like I do need to show the parameters tab. So let me first talk over the cylinder layers here. Now these layers are quite basic. There's nothing special going on in here. I do have an empty for the weight state over here. And all I've got is if the color is equals 0, then becomes white. And if the color becomes 1, then it becomes red. And if it becomes blue, if it becomes 2, it becomes blue. So this is pretty straightforward throughput no stuff. Like there's nothing special going on in here at all. So if I take a look at my parameters, these are how my parameters, this is how my parameters are laid out. I just have it exactly the same as my color over here. My cube is the exact same here. And my sphere is the exact same here. All right. All right, so we've done quite a few things on the back end. Let's take a minute to look at how it looks visually in the front end. So let me quickly go into play. And then go to scene. And then go to my parent again and then start changing this around. And as you can see, it still works the exact same way as it did before. All right. So we need to ask ourselves right now, what have we actually gained from doing this? Because we have a ton of new animation files that we didn't have before. And we actually have no real difference in the front end, right? So there are actually quite a few things we can talk about. The first thing being modifiability. We can easily change specific animations right now, or layers, to change specific functionalities of the system. So if you recall, we separated each animation and each layer into its own requirement. So now we can easily change each individual piece without like damaging other layers or other systems, which is really cool. Scalability. We can easily add more layers that extend on the color profile by simply adding that parameter in the parameter driver layer. We've also increased our modularity since we can remove, replace, or even upgrade layers without affecting other layers. And, well, probably the coolest thing that I've not mentioned explicitly is being able to perform a chain of actions that are not directly linked to the original parameter that was activated. So that's especially cool for like things like character transformations, like activating like a demon mode or whatever, like something like that. And well, I'm sure there are many more benefits you might see, but hopefully you can see how this is so much better than the previous solution that we had. I'll make sure to attach the Unity project for this in the description so you can take a look for yourself. And I hope you learned something today and have a great day. Bye-bye.